paper,
Okay.
next topic. And
Thank you.
but if you have any questions for Qinghao, please leave your questions in the chat box. Our next presentation is about construction robotics, and the title of the presentation is Construction Robotics Excellence Model, a framework to overcome existing barriers for the implementation of robotics in the construction industry.
My name is Jan-Iwo from the Jakel Institute for Construction Management, Digital Engineering and Robotics in Construction from the RWTH Aachen, and today I want to present you our paper, Construction Robotics Excellence Model, a framework to overcome existing barriers for the implementation of robotics in the construction industry. First, I want to give you a short introduction on our structure of the presentation. First, I give a short introduction and the research target. Then I introduce you into our methodology. Then we talk about related works and the meta barriers in the area of construction robotics. After that, I will talk about our empirical quantitative study. And then, after all, development of the construction robotics excellence model, and in the end, a small conclusion about the topic and our paper. The construction industry has a huge relevance in the world's economy. It has a large economic output and a high social relevance due to the employment of a high amount of people, and even in the context of the sustainability. In the contrast to that, we still suffer inefficiency and a low productivity for the last 2 or 3 decades. And also we have a low level of digitalization and automation in the direct comparison to other business sectors. On the other hand, we have knowledge about automation and robotic systems since the late 60s, we have been developed robotic systems in research in the construction sector. So there exists knowledge here in our industry about the function, the use of robotic systems, the fields of application, the big values for the industry, and still the existing barriers. But till now, there's no framework and no guideline to implement construction robotics into different enterprises. So our target is the development of the Construction Robotics Excellence Model, which is a framework to overcome the existing barriers and functions as a strategic guideline for the implementation of robotic systems in the construction enterprises. Our methodology starts with a literature review and the identification of existing barriers. We find meta barriers in which we clustered the identified existing barriers in a worldwide view. In the second stage, we conducted an empirical quantitative study as a web survey and identified existing barriers specified for the German construction industry. Then the third step, we combined the knowledge and did a derivation of an A+ for the implementation for construction robotics, and out of that we developed the Construction Robotics Excellence Model. So first, in the literature review, we used scientific databases and identified in total 9 major scientific papers with a total of 52 existing barriers. These barriers we clustered into 5 meta barriers and did a differentiation into 3 levels, into technical barriers, commercial barriers, and social barriers. So in the end, we defined 5 meta barriers. First, the adoption, the implementation, which contains barriers like the complexity and the fragmentation in the construction industry. The second one is the skeptical attitude on the social level, like skeptical attitude from workers against the automation and the use of robotic systems in outside and on-site. The third meta barrier are high costs for the implementation of and the use and the maintenance of robotic systems for the enterprises. Then the fourth one is lack of knowledge, which still exists on the operational side, the workers and the managers. And the fifth one is there's no standardization for the specific use of robots in offsite and onsite construction till now. Out of that, we conducted an empirical quantitative study focused on barriers in the German construction industry. In total, we had 65 participating experts, where we had a limitation. Just experts and specialists in the area of the construction industry were allowed to attend the survey, and we really focused on companies in Germany due to the existing fragmentation in the German construction industry. We had 2 major topics. First, we asked about experience with construction robotics, where you can see here below down in figure 1 the results, and then the second part was the survey about the barriers which exist. We see that on the next page here. On the first result, the figure 1, the use of robotic systems and experience, still 3 out of 4 people in the construction industry don't have any experience in the use of robotic systems, and about 26.3% have knowledge either in the on-site processes or in the prefabrication. So that really shows the necessity of a holistic framework for enterprises to implement and use robotic systems in the future. The second part of our survey was to identify the barriers. The questionnaires could evaluate 32 predefined hypotheses, and they could rank them in an unipolar ordinal scale from a total of 6 response options, ranging them from disagree to strongly agree. And out of that, we had a subdivision of these hypotheses in 3 levels: technical, commercial, and social. After the execution of the survey, we ranked the hypotheses and integrated them into our cluster of meta barriers. Here's an outtake of the results. In the end, we had 3 barriers in the German construction industry on the social level. We had 2 on the technical level and 7 on the commercial level. Like on the social level, the lack of advanced training, a low level of employee expertise, and the lack of knowledge about the possible applications. On the technical side, there's the part of the non-standardization and the very dynamic construction site environment. On a commercial level, we have something like high cost, limited resources, and a lack of governmental support or skilled workers to implement construction robotic systems. Out of our knowledge, we, from the literature view of existing barriers and the results of the barriers for German construction industry, we did a derivation of enablers out of our barriers from the survey and our meta barriers. And in the end, we developed enablers to support and push the implementation of robotic systems into the enterprises. And out of this, we developed the construction execution model in connection with the knowledge out of existing excellence models from different industries. There you see the result of our construction excellence model. Here in figure 2 on the left side, we have the potentials that you need to know, business capabilities and robotic capabilities. And out of that, you can define your robotic strategy, your robotic objectives of the company, and potential use cases. And then we identified the 7 enablers, which you need to focus on for a smooth implementation. And these enablers focus on the level of the organization, the processes, the data, and the application system, as well as the legal and regulation, and on the social level with the responsibilities, roles, training, and education. And when you have a continuous improvement in these major factors, you can have as a result the rising business value, the business excellence, and the robotic excellence in your projects. And the big one is that you need a pursuit of excellence to achieve these goals. And in the end, our conclusion is our paper presents a holistic framework for the adoption of construction robotics. It's based on existing knowledge and the results of our empirical study. We have the Conrax model as a guideline for construction companies who want to implement robotic systems in their structures. The model minimizes existing obstacles, incorporate redundancies to adopt robotics, and the use will simplify the implementation. We have also some limitations. The model is a first generic approach, so we had a limited number of experts participating in the survey, and there's no further verification and practical validation of the first approach. So out of this, we have future research activities in our institute that we need further scientific review and specification, for example, with other experts in this field, and we need further specification of the individual parts of the Conrax model. And in the end, the model needs to be tested in use cases for its sustainability with companies. So thank you very much for your attention, and if you have further questions, please contact me via email. Thank you very much.
Assume no authors in this paper were not in this room, right? So yeah, if you have questions, so please know the email address of the authors. Please send your questions to the authors. And last but not least, I guess I'm not a good project manager if I work in the industry. The project is delayed. So our next on the presentation will be about the state of advances in reality capture for construction progress monitoring and documentation.
The next presentation, the president is unable to attend here, so we can finish now for the session.
Okay. So, well, that is not expected, but anyway, I guess that's all for this session. And in the session, we have 5 wonderful presentations covering the construction education, safety, robotics, monitoring of the construction performance. So it's very wonderful to see all the authors and communicating with each other. And also it's my great pleasure to share this session. Thank you all and enjoy the remaining days of the conference. Thank you.
Thank you. So we can go to the break, and we are having the final keynote on the MLB after 5. Thank you.
Logramos esse auditório.